So here's another problem, and I want to know if this series, series is the sum as n goes from 1 to infinity of n plus 1 over n cubed plus 1, does it converge or diverge? So look at the numerator. What's the highest degree? 1. On the denominator, the highest degree is 3. These are the terms that are kind of in control of the whole series. Just like that algebra problem I started class with, that these are going to be, as n goes to infinity, so they don't matter. These are going to determine what's going on. So I want to do this. I'm going to use the series as n goes from 1 to infinity of n over n cubed as b sub n. I'll just use that to compare. Now you can reduce this n over n cubed. So that's the series as n goes from 1 to infinity of n over n cubed, and that equals the series as n goes from 1 to infinity of 1 over n squared. And you know what happens to this. It does what? That converges. So now we have to say, okay, well, let's see. A sub n is n plus 1 over n cubed plus n. And we need to know this is a sub n less than or equal to b sub n. Since b sub n converges, series b sub n converges, if I'm going to use the first of the comparison test, I'd have to say, is this true? Now, I'm looking at this problem, and this would be n plus 1 over n cubed plus n. Is it, I'm going to put a question mark there, is it less than or equal to 1 over n squared? Now, this is where you might be looking and thinking, okay, now what does that plus 1 do? What does that plus n do that's in the denominator? Okay, I'm going to solve this out, and I'm looking at this. N's are positive, correct? They're going to infinity. So n's are positive. I am going to multiply both sides by n squared and by this n cubed plus n. So it'll be n squared times n cubed plus n times n plus 1 over n cubed plus n, 1 over n squared times n squared times n cubed plus n. And I didn't put my less than or equal to because I want you to think about this, although we've already thought about it a little bit. Do I need to flip the inequality sign? Remember, high school on inequality, if you were multiplying or dividing by a negative number, you had to flip it. Do I need to flip it? No, because n is going to infinity. So that's less than, and this is still my question mark. This is the question we're trying to answer right here. Let's see, these cancel, and so these are gone, and I have n squared times n plus 1, that's n cubed plus n squared. Is that smaller than or equal to n cubed plus n? Something's not quite. Did I make a mistake in there? No, I don't think so. Okay, I might have to take a second look at this one. But I'm thinking at this point, is that inequality there for me? N cubed plus n squared, is that smaller than or equal to n cubed? Is n squared smaller than or equal to n as n goes to infinity? Yeah.
What was your purpose of multiplying was to try and get a like denominator?
Just to try to make some decision about what's going on with this problem.
Okay.
Yeah. Is it?
I mean, could you do that though?
You
Get a like denominator and kind of compare them
You could do that.
and just see if they're,
You could do that.
okay.
So, I'm looking at this and I'm thinking there may be a little mistake in there, but if this is correct, I don't have my inequality that I need. This is not true. So, I have to do something else. That's the second of the comparison tests. So got stuck right here. And I'm saying I got stuck. I have a pretty good idea that this series is going to converge. But I don't have this inequality. And again, I want to take another look at this after class, and if I need to, I'll redo the video. But I don't have this inequality at this point. I cannot use the comparison test. Yes?